We start today with a warm-up. Write the first 6 terms of the following sequence, where a sub 1 is 1, a sub 2 is 1, and then everything after that is the previous one, so minus 1, and the second previous one added together, which means a sub 3 is equal to the 2 previous added together, which is 2. And then a sub 4 is equal to the previous 2 added together, which is 2 and 1 is 3. A sub 5 is equal to 3 plus 2. And if we plug the numbers in, a sub 5 is a sub 4 plus, and if you plug 5 in here, plus a sub 3. So a sub 4 is 3, a sub 3 is 2, so the next one's 5. And then a sub 6 is the previous 2 added together, which would be 8. Sequences and summation notation. Write the first 4 terms of the sequence whose nth term or general term is given. So a sub n equals 2n plus 5. This is an explicit formula. Explicit. Which means we could jump to the 100th term no problem just by plugging in 100. So we're going to plug in 1. And 2 times 1 plus 5 is 7. A sub 2 is equal to 2 times 2 plus 5, which is going to be 9. A sub 3 is 2 times 3 plus 5, which is 11. And then a sub 4 is 2 times 4 plus 5, which is 8, which is 13. Now, a sub 1 here is negative 1 to the first over 2 to the first plus 1. That's going to be negative 1 over 3. A sub 2 now is negative 1 squared. Well, that's going to be positive over 2 squared plus 1. That's going to be a positive 1 over 5. And we call this an alternating sequence because it's going to go negative, positive, and so on. A sub 3 is negative 1 to the third over 2 to the third plus 1. That's negative 1 over 9. 2 to the third is 8. And then the fourth term, a sub 4, is negative 1 to the fourth over 2 to the fourth plus 1. And that's going to be positive, 1 over 17. Find the first 4 terms of the sequence in which a sub 1 is 3, and a sub n is the previous term times 2 plus 5 for n greater than or equal to 2. This is called the recursive formula. Because it takes previous terms, you have to know previous terms to get the one you want. Well, we know a sub 1 is 3. A sub 2 is going to be 2 times a sub 1 plus 5, when you plug 2 in for that n right there, which is 2 times 3 plus 5. So that's 11. A sub 3 is 2 times the a sub 2, which is 11, plus 5, and that's going to be 27. A sub 4 is the previous term times 2 plus 5. That's, let's see, that's going to be 54. I'm getting 59. 59. Yep. Write the first 4 terms of the sequence whose nth term is, well, now we have factorial. 0 factorial is 1. 1 factorial is also 1. 2 factorial is 1 times 2, which is 2. 3 factorial is 1 times 2 times 3, that's 6. 4 factorial is 1 through 3, but then times 4, so 6 times 4 is 24. 5 factorial is 5 times that, that's 120. And we usually stop with 6 factorial, that's 720. And I have my calculus students memorize these because we use them quite often. And the more you have them memorized, the quicker the math will go when you have to decide, well, what is 4 factorial? A sub 1, in this case, is 20 over 2 factorial. That's going to be 10, because 2 factorial is 2. A sub 2 is 20 over 3 factorial. That's 20 over 6, and that's 10 thirds. A sub 3 is 20 over 4, let's see, I'm plugging in, 4 factorial, 24. 4 goes into both of those, 5, 6. A sub 4 is 20 over 5 factorial, which is 120. I can divide both by 10. So we're looking at 1/6. Evaluate each factorial expression. Well, 14, I would really like to cancel out the 12 factorials here. And since 14 factorial is 1 times 2 times 3 times 4, keep on going. And then we can go times 12 times 13 times 14. We can write 14 factorial as 12 factorial, but then times 13 times 14. And that's still 14 factorial. Over 2 factorial times 12 factorial. Now these can cancel out. And we're left with 13 times 14 over 2 factorial, which happens to be 2. We end up with 13 times 7 because 14 divided by 2 is 7. And 21, I think 91, 7 times 13. Well, we're going to do something similar here, and we're going to try to get one of these. I want the top one to be in terms of n minus 1 factorial, or the bottom in terms of n factorial. And what we can do is we can write the top as n minus 1 factorial, and then times n. So in other words, we can write, and we did the same thing right here. We did, if n is 14, we actually did n minus 2 factorial times n minus 1 times n factorial. So in other words, this is the number just previous to n, whatever n is, over n minus 1 factorial. Well, now these two cancel out and we're left with n. Now, if you want to see if what you did was correct, just pick a value for n. So like, let's say n equals 6. Well, now we're saying 5 factorial times 6 over 5 factorial. Well, those cancel out, and we're left with n. We're left with 6, which is n. So it seemed to work. Expand and evaluate the sum. Now we have summation notation. We have sigma notation is what they also call it. This means add up a bunch of these. And we're going to plug in 1, then we're going to plug in 2, then 3, then 4, then 5, then 6. So all of this is telling us to do the following. We're going to take 2 times 1 squared. And then we're going to add. Now it's add because sigma notation means to add stuff up. It's a sum. Plus 2 times 2 squared. 2 times 3 squared. 2 times 4 squared, 2 times 5 squared, and then 2 times 6 squared, because we're going from 1 to 6. So 2 plus 8 plus, that's 18. 16 times 2 is 32. 25 times 2 is 50. And then 36 times 2 is 72. Let's grab a calculator, save a little time here. We got 2 plus 8 plus 18 plus 32 plus 50 plus 72. And we get 182. 182. So there's A. Letter B, instead of starting at 1, we're going to start at 3. So all we have to plug in is 3, 4, and 5. So 2 to the third minus 3, 2 to the fourth minus 3, plus 2 to the fifth minus 3. So 8 minus 3 is 5. 16 minus 3 is 13. 32 minus 3 is 29. So 18 and 29. I'm getting 47 for this one. Letter C can be the most confusing. And there's just no place to plug in 1 and 2 and 3 and 4 and 5. But so we just have all 4s. It's 4 plus 4. There's plugging in 1. There's plugging in 2, 3, 4. There's plugging in 5. So 5 times 4 is 20. Express each sum using summation notation. So that's sigma notation. And we're going to go either I, or sometimes you use K. I equals 1 to, it looks like 9. 1 to 9. And it looks like 1 squared, 2 squared, 3 squared. So we're adding up I squared. That's the pattern for this one. On this one, we're going to go from I equals, we go 0, 2, 4, 8. Not 0, but, 2 to the first, 2 squared, 2 to the third. So this is 2 to the 0 is what I meant to say. So let's start at 0. Let's start at 0, and we're going to go all the way to n. And we have 1 over 2 to the I. because that'll be 2 to the 0, 2 to the first, 2 to the second, 2 to the third, and so on. This one down here, this one seems to be what we say. We say it's linear because we're going to add 4, and then we're going to add 4, and then we're going to add 4. So it seems like we're adding 4 every time, and that's a linear growth there. It's growing by the same amount. Each term is growing by the same amount. Let's get the sigma, and let's decide what we're going to start with later. But if something is increasing by 4, that means the slope of this line is let's say 4 times I, because we're using I, right? But if we plug in 1, we get 4. When I plug in 1, I want to get 6. So we have 4I and then plus 2. Now if I plug in 1, I'm going to get 6. So I equals 1, 2, and we'll decide how far we have to go with this. This is going to be 4I plus 2. And we're going to have to go to, it looks like 10, because 10 times 4 is 40, plus 2 is 42. So we're going from 1 to 10. Now that's a linear relationship. It's increasing by 4 every time. And then we have this exit ticket that I would like you to upload to Google Classroom. Please, it's number 2 and number 14 straight out of the book.